Hello, everybody. My name is Nathan Wood. I'm the founder and CEO with Spectrum AEC. Very excited to be presenting for all of you. I'm so sorry I cannot be down there in person. I hope the weather is great down in Brazil. But want to talk about my lessons and experiences and really my journey of understanding Lean and BIM in my time with DPR construction in the California area. So a brief history about myself. I grew up in Boulder, Colorado, as you can see here, right up against the Rocky Mountains, very beautiful home, and went down to Austin, Texas, where the University of Texas is, and studied civil engineering, got my engineering bachelor's degree, and went to work for DPR first as an intern, doing data center construction in Washington, D.C. area, and then eventually ended up full-time in San Francisco, California, working in BIM and project engineering and integrated project delivery for two different projects for Sutter Health that we're going to be talking about quite a bit today. After that point, though, I was able to join DPR's innovation team and got some very interesting opportunity to spend time researching BIM in Abu Dhabi and in the Middle East and Qatar, and learned really from the other side of the world how contractors use BIM, sort of became a BIM trainee again, so to speak, and saw some interesting ways that they were using BIM for site logistics and quantity takeoffs and manpower tracking, and many ways that we were not using BIM in the US. But ultimately also learned that while they were using a lot of BIM and there was a lot of really great data from BIM, there was a lot of paper, a lot of inefficiencies, and still a lot of room for improvement even out there as well. I took those experiences and was able to share those with another large contractor in Denmark through DPR's consulting group. It was very interesting to see how they approach Lean and collaboration and integrated BIM and 5D. And so learned a lot from that experience, I think on both sides of the aisle. And then last year, I left DPR and started Spectrum AEC, which is really intended to focus on understanding that choosing technology is just one aspect of really the innovation process, and that it starts first by understanding the needs of the people, the needs of the project team, how to define really good lean process through that, and then choosing the best fit technology. And that's really what brings me to the lesson and the story that I want to deliver to you about my BIM implementation journey. And really everybody's BIM implementation journey will be a little bit different. I think it's very easy to start with, what is BIM? And in the US, I prefer the US National BIM Standard definition. You can see here from 2007. It says, a digital representation of physical and functional characteristics of a facility. A BIM is a shared knowledge resource for information about a facility, forming a reliable basis for decisions during its life cycle. So really emphasizing that it's a shared knowledge resource and that it should be a reliable basis for making decisions on the project. Now, often we really want to jump into, okay, how do we do BIM? What is the 3D coordination steps? How do we do 4D scheduling? How do we do 5D cost estimating? How do we do 6D for facilities management, or the XD, which could be into energy modeling or other systems that are very pushing the limits of technology. But I think that's a lot of discussion that you'll see examples of. And I think too often we get distracted by many of the how, and we forget to skip over the first step, which is really why. Why should we use BIM in the first place? And knowing that why we use BIM in California may be different than why Brazil will use BIM. All right, so why did Sutter Health really care to do BIM in the first place? Their challenge was driven by something we call OSHPD, the Office of Statewide Health Planning and Development, which is really centered around ensuring that critical care healthcare facilities stand up in one of the many earthquakes that some of you have ever seen a Hollywood movie around San Francisco know is not a common occurrence, but something we certainly have to prepare for in a critical event. And so very important, not only that these hospitals are very well built and stand up through earthquakes, but there is a very strict timeline of when they had to build that. And so what BIM was really focused on was based on those challenges of detailed structural coordination, understanding and using Tekla structures, which is a BIM software originally developed for structural steel that now is developed around concrete works and rebar, and we were even using it for exterior skin extrusions and other facade works and some of those connections, as you can see here. But really, how did they do it was a combination of BIM and Lean and integrated project delivery. You can see below here is the 11 different parties of the integrated form of agreement that Sutter Health signed to really bring all of the shared risk and shared reward together. And some of the goals and the key performance indicators that they had set out that was very important to their success was that they had set a need and a goal of 30% reduction in the design and construction schedule. They planned on using BIM and Lean as a way to really drive that 30% reduction. They didn't want to see any rework. That was a really key part of it. And in order to not have rework in the field, that meant that we had to track the rework. And as we have less rework, I think the intent is that we should have increased field crew productivity, and we should be looking for innovations through prefabrication and modularization to increase that field crew productivity. And really, ultimately, the vision, and you can see below, this was actually an IGLC paper in 2014 that was written by Digby Christian of Sutter Health around this 4-phase integrated project delivery that goes through the value definition, the representation, the realization, and the value capture. And BIM is really a great enabler of that, of starting with the visual representation and the needs, moving into a really coordinated, detailed BIM that is at that point of release in order to realize that BIM and capture a really well-produced facility in less time. But I think in reality, and what we have seen very much on a lot of these projects, and Castro Valley was included in this, is that the real world process is much more of a 3D to 2D process, and that design engineers will typically create a Revit BIM that produces a 2D set of permitted drawings for the city to review. And then the detailer will often take those and create their shop drawings from there. And then from there, we'll see the detailer create their own separate set of shop drawings from that, in which case the designer will come in, review those drawings, and then those shop drawings are what end up going off to the contractor. So very often the question and the risk when it comes to this level of detailed BIM and wanting to not have any MEP rework or any rework was, can we be confident that the model that's created from the designer is the same as the 3D model created from the detailer? And sure enough, as we did some of those overlays and investigations, we found out that they were not aligned and that there needed to be some reconciliation between those two designs, that there was not a reliable transfer of information. You can also see that this also impacts downstream when we're dealing with amount of information, amount of detail within a level of development that is 300 versus a level of development that is 400. Seeing there that could be a very expensive $30,000 clash in the field that we want to definitely make sure that we identify ahead of time and capture that value within BIM coordination. So one of the really great direct BIM uses is the direct transfer of 3D coordinated shop drawings or 3D coordinated models to those 2D shop drawing outputs, doing that with both rebar works and some very complex and dense rebar coordination, as well as the coordination of all of the embeds and penetrations that were required for the exterior skin system on the project. Now, it was actually during this process of coordinating these two that we realized and came about a clash that was in the model between the penetrations that were required for the precast facade system and the concrete core walls. So you can see here where the 4 or 5 different red dots there were penetrations that needed to be moved. Other areas where embeds within the concrete deck were conflicting with structural steel elements. So overall found at least 50 or 60 different elements that needed to have a structural redesign and a new approval gone through OSHPD. And it was very fortunate for us to identify these ahead of time to be able to really avoid and mitigate that risk. And so you can see here, and we not only gained the mitigation of the risk, but really an efficiency of direct transfer from BIM to 2D drawings to field layout, and a high quality at, I believe DPR Concrete reported a 10% productivity increase through this BIM to field layout process. So one of the lessons learned as we continue to research how does the model information get from design to construction, when it came to the facade itself, we looked at where the architect was creating their 3D model that would create 2D drawings and pass along to a design assist subcontractor that was creating the fabrication drawings. And they would create shop drawings, and we go through a comment process in the design assist process. And ultimately, we would actually have two different sets of drawings that would go in for permit to the city. Now, once again, we run into the question of, is there a reliable handoff of information in this very manual collaborative process? And what we did was we took those same shop drawings from the field, or from the fabrication, moved them back into BIM, asked for the CAD drawings, aligned the CAD drawings within BIM, and then within Tekla, you can see here, we took 50 or 60 different of the 2D CAD elevations, aligned them appropriately on the grid lines, and virtually traced the as-built or as-will-be fabricated model of the different skin systems. And so where this becomes interesting is that now we have two drawings and two models. So by comparing the design model from the architect and the fabrication model, which is a combination of multiple trades, we can now see where there's any differences or any discrepancies. And we did identify a couple of them at first. One was a simple miscommunication over a window that had to be moved for some framing that fortunately was captured before release for fabrication. Same with this, with glazing, just a height of a curb that was misunderstood and could have resulted in a lot of headaches and challenges in the field, and fortunately was identified ahead of time, and we mitigated that risk. Other areas that had no design at all, that we saw interesting intersections of multiple trades that was basically a design gap, and we had to use BIM in order to find out how do we design where this opening in the building is going to be. And using BIM, we were able to show exactly where the opening needed to be cut in the precast so that the metal retaining wall, or sorry, the metal panel wall could die into that. And you can see that the dimensions needed for that fabrication were pulled straight from the model. They asked what those dimensions should be. We're able to provide exact dimensions through BIM, and we're able to see that updated cut, fabricated and shipped out to site, cut well, and you can see the final product there without having to do any field cuts. So some other interesting uses for BIM on the Castro Valley project were just simple overlays of 2D details that helped us identify areas where maybe we needed to provide a flat strap for better waterproofing, or understanding the constructability of a door frame around a curb and the constructability in the sequence. And even, building that out further and really identifying with the field, how do they want to build it, and can we build it correctly in 3D and then represent those details back on the 2D drawings. Now, an interesting story, and I think the last story that I'll leave you with from the Castro Valley project was the need for modeling of the tapered insulation of the podium roof. Now, this would not normally be something that you would model in BIM, but it was an interesting use case where we investigated to see, could we find any constructability issues? And sure enough, found 30 plus locations where the structural steel plate for the kicker was too low, and that the amount of tapered insulation was going to be coming higher than the edge of that, and wasn't going to be a waterproofed condition. So it was sort of a last minute rush to really bring the team together and come up with a new design for the roof that was not going to taper all the way up to the tower level, but would break in the middle. And you can see there was a need for 3 new drains, and those drains would be routed to an existing storm drain riser. Now, this was definitely came to a challenge for the MEP team, because they were frantically coordinating all of the massive equipment and everything on this roof. But we were able to get that redesigned and get that done. And really how is through that shared risk and reward within the IPD team. And the fact that just because the steel and the roof were having challenges in their trades, that the MEP trades that were already busy with their own work were able to go out of their way and support the team for the greater good, solve that problem, and get that concrete poured on time. So really great use of collaboration, integrated project delivery, lean, and BIM coordination. Now, I actually left the Castro Valley project to go to Alta Base, but I do want to talk quickly about really the efficiencies and the benefits that the MEP team got after I left the Castro Valley project. Now, this is an example where we can really see the plumbing detail from what they have coordinated in the model to an automated spool sheet that they have inside of their CAD systems that provide exact bill of materials and exact lengths and cuts. They use a tagging and a kit of parts, very much a lean mentality, to have each part and piece tagged and shipped and inserted on rollers for easy access. And really that is the level of consistency, the level of reliability that we need as the general contractor in order to trust that what's in that model is equal to what's in that field. Another way that the trades are able to gain that consistency and that reliability is through the use of integrated total stations. So the robotic total stations that are often used for surveying are now being used up on metal decks to coordinate the hundreds and hundreds and hundreds of inserts that are required for the OSHPD compliant seismic joints. So again, this is a sort of a unique challenge to the San Francisco Bay Area, but a very innovative use of integrated BIM to field using the robotic total station and showing a 4 times productivity compared to the conventional layout. And really, because of this level of consistency and reliability from BIM to field, it now opens new opportunities for innovation and process disruption, like where DPR drywall now is using Revit and using the metal wood framer application and plugin to detail all of the light gauge framing for their drywall systems around the existing MEP openings, because they understand and they trust that that information is going to be in that exact location out in the field. And you can see that they're developing their 2D layout drawings from that information that they use on the tablet or print out on an A3 size sheet. And they're actually now able to go out and lay out openings prior to the MEP going out and laying out. It's an interesting change in process for the field that really produced some great efficiencies. And you can see that here in the fact that, you know, from the baseline estimates of reduction in rework, you can see anywhere from a 50 to a 95% reduction in rework, which is, you know, just some phenomenal statistics from the Castro Valley project, as well as a 5 to 28% increase in productivity. You can see here the greatest productivity increase by drywall because of that innovation of using BIM for the light gauge framing. But as I had said before, in fall of 2010, I left the Castro Valley project. I was sort of asked to take some of the things that we had learned from the structure and the exterior skin systems and bring that to the sister project for Sutter Health, which was the Alta Bates Patient Tower. And again, this was a similar $300 million, 189 bed tower. And it was intentionally delayed 1 year from the Castro Valley project in order to capture the lessons learned and really share those. So while they did share many of the same challenges and lessons learned, there were some very unique challenges to this Alta Bates project. So one of those challenges was the unforeseen conditions. You can see here there's a 9-story dormitory in the place of the patient tower that had to be demolished first. It was quite a complex project site, not just the geometry of the tower itself, but really the proximity to the existing hospital that needed to remain operating, and just very, very limited site as it was in downtown Oakland. So one of the interesting uses of BIM that we did early on in this project was modeling of temporary structures like the tower crane location and the final heights, as well as the embeds for that tower crane that were going to be embedded within one of the permanent foundations. And it really helped us understand that temporary structures do have a fairly significant impact on the final project, and that they do need to be coordinated in sequence within the project. And again, having that faith and trust in the BIM information for the mechanical, electrical allowed us to create those heights and use a lot of this information for even getting the crane submittal and crane permit from the city. On the Alta Bates project, we did some interesting exploration with the use of 4D, and this was really when the Synchro tool was really getting good traction of being able to combine a Primavera P6 schedule with the different locations and trades and zones, and to understand sort of the orchestra or the dance that goes on between different trades. And this is really a great way to visualize where different trades are going to be at different times on the project, and help look for both safety and constructability issues. Another use that had just come out in around 2011 was Tekla BIM site, which was trying to be a much more collaborative sort of markup and task-driven BIM collaboration tool. And we use that to communicate a lot of the challenges that we were finding in the exterior skin coordination against the existing structure. So here would be one example where there is no wall designed within the system, sort of asking, should there be a wall there? Other ones where we found new conditions out on site that hadn't been documented in the existing conditions model and needed to be. So it's a great way to correlate photos and markups to ensure that we had a reliability between our as-built BIM that we were referencing and what was actually going on out on site. When it came to DPR concrete and the innovation in layout efficiencies, really taking the shop drawing layout to the next level and understanding the pore optimization, and then utilizing the robotic total station that was being used for the MEP inserts, and now using that for concrete and anchor bolt layouts. But at the end of the day, I think the same challenges as Castro Valley and an increased challenge in all debates was this very in-depth need to understand where is the real existing conditions compared to what BIM expects those conditions to be, because we're using so much accuracy and detail in the coordination of BIM. So one way that we were able to gain that reliability up front was the use of both laser scanning and robotic total station. Now, it was an interesting lesson learned that there are different uses for different conditions, where a laser scanning, as you can see, the red point cloud would be a much larger mesh of millions of points to understand where deviations in the face of a certain building are, or just a larger area of points. If there are more exact things that we need to understand, like the door thresholds that you can see here, where we're going to be connecting in at doorways, sometimes it's actually better to have individual points from the total station to give you that really high level of accuracy and confidence. But as we continued the mass excavation and started doing the lower foundation piles, we came into more challenges with very dense, structural rebar coordination and some constructability challenges. And what had happened was that some of the piles that were drilled from the large augers you can see there were offset. And so what we did proactively was to identify and understand as early as possible when were any of these piles going to be out of place. And you can see here those that were in red that required an OSH-pod design change that was going to take an additional 2 weeks, or others that we had an existing fix, but we needed to order the rebar in order to make those fixes. So a great way of understanding where deviations are and addressing those design issues ahead of time. In addition to layout deviations, we also found existing conditions that were unforeseen conditions during mass excavation, and needed to determine a quick action plan of how to resolve those issues. One example here in the corner, we found some existing soldier piles that were not originally documented, and they were going to conflict with a pile cap that we had there, you can see in yellow. What we were able to do was identify exactly which piles were going to be interrupting the auger cast piles, which ones were only going to disrupt the foundation, and which ones we did not need to remove at all. So definitely saved some time and some headache not having to remove all of those and only removing certain ones. On the other side here was an example of an existing bell footing that could not be removed, that was part of a structural element, and we needed to coordinate the very dense, it was in the US we call it number 9 rebar that cannot be bent on site. And so if you see the light green dots are the total station as-built points, so that we knew exactly where that concrete element was, exactly where the rebar needed to be bent. And you can see in that picture there that all that rebar was bent exactly on those angles off-site and delivered, knowing that would fit in place through the coordinated model. But ultimately, with the OSH-pod permit and the submittal approval, a lot of this does still have to go through a 2D review set. We were utilizing the Bluebeam Review and Bluebeam Studio as a way to cloud review and really accelerate that 3D to 2D to review to fabrication process, creating a lean workflow from BIM to 2D to fabrication. And one example you can see here in one of the collaborative working sessions, the value is that if a question does come up from the engineer, and you can see here there were some questions in orange trying to verify some of these bars that were included in the submittal for this package, and there was a response directly from the detailer who created the drawings, clarifying exactly the answer that was needed. This really allows these drawings to be stamped as revised as noted and released for fabrication rather than the dreaded revise and resubmit, which is very difficult to make up schedule time without that. Now, there were certain situations where even the 2D drawings were, we could not understand because we had to go all the way into BIM to understand the coordination between the structural steel elements and some of the penetration holes for where the rebar needed to sort of string through the design. And an interesting collaboration effort, again, use of IPD, shared risk and reward, and integrated BIM to combine Tekla rebar and Tekla structural steel and identify a constructible design and get that fabricated and shipped on site. Now, while we did do a lot of 4D scheduling in Synchro and testing the uses of 4D, really the benefit that I found most with using 4D was more at a micro level of truly understanding the incremental sequences. And one of the unique sequences for the structure of this building that was part of the innovations to make up schedule on the construction time was that they were going to pour the concrete walls first in the basement, then come in with the structural steel framing prior to the concrete core walls, and then the 3 concrete core walls around the elevator, the central core, and the stair core will be coming up after the steel's been erected. So a little bit of an inverse process. And in looking at that and identifying how that was going to work inside BIM, we recognized that their sequence was going to have walls placed before columns, and the welding access was not going to be available. And thankfully, we identified this prior to that wall there being poured. So what we did was we thought up an innovation and said, well, let's open up a 2-foot by 2-foot opening and find a structural detail that is acceptable for that. And this whole area of wall on the other side, we knew that we could move where the pour joint was going to be in order to leave open access for that welding in that corner. So we picked that up later on the after in the elevator core. So you can see here when that wall does pour in after the welding's been done, very easy to patch that up. We do leave the other wall open up until when the elevator core walls comes in. Then we can see that section poured in. And once again, just one of many innovations and lean process and integrated BIM to field with Total Station that helped this team save 33% on the submittal reviews for the rebar, which really contributed with all of those aspects to make up the 31 days of critical path schedule that was recovered over the 10 months of foundation work. So really great achievements for this project, up front. One of the last stories that was, sort of near and dear to my heart that was a very difficult challenge on this project was the coordination of the civil and the structural design. As you can see here in white, there's a driveway that comes up and over the structure of the building, moves out onto a bridge that extends over an underground auditorium before coming back to street level. And so very complex and highly structural design. You can see here the information that we were basing off of was a structural Revit model. And we had sort of a polyline that was from Civil 3D from the civil engineer of what the top elevation needed to be. And we were able to align the grid lines on that and see those together in Tekla. Now, what we found was that there was quite a significant scope gap in between the top elevation of what was needed and where the structural concrete was. And knowing that we had to basically manage weight limits and structural limits and a lot of different variables that need to be coordinated. But within BIM, we're able to coordinate all those, get those answers, and ensure that it was constructible and met the design intent using Tekla structures. And actually the 2D drawings that were used to submit that change back to the city of what was coordinated was created directly from the 3D BIM in Tekla and then used and referenced by the structural engineer in order to get the OSHPOD approval of it. So not the most lean approach, but definitely an innovative and lean approach to using BIM to solve a very complex coordination challenge. And the last thing that they used was an even more detailed integration of the BIM to field using the total station. And as you can see, all of the little red dots that follow along that curb that is sort of serpentine and comes up and down as you go. Now they're able to use total station to have the X, the Y, and the Z coordinate so that they could know exactly where that goes. And you can see it's a different type of receiver that's called a peanut prism that's used by the field in order to get the level of accuracy of X, Y, and Z. And so you can see here what that pour looks like after the fact as they went along. And so, you know, it's now 2016 and the Alta Bates project is finished. It's a beautiful hospital. The drive aisle, I think, you know, turned out great. But in reality, the financial and the time, the schedule outcome were not as expected for an integrated project delivery. And there was actually an interesting IGLC paper, again, by Glenn Ballard that I helped co-author called How to Make Shared Risk and Reward Sustainable, that you can see here and look up if you want to read more information on how to avoid some of the pitfalls of this project. But ultimately, it was sort of an interesting question of two projects so similar, really trying to capture lessons learned, while one of them, you know, finished 6 weeks ahead of schedule and was able to maintain their target's cost. And why was it that Alta Bates, you know, was delivered 6 months behind schedule and at 20 million over the target cost? I mean, I think you can see that there were certainly significant challenges on that project. But as we really ask why, I think if both projects did BIM, if both projects really were performing the lean process, and if they both had the IPD contract, what really was the difference? And there's a really great article that came out in 2011 around the Castro Valley project from the Engineering News Record that you can look up online. And there's some quotes here from the team about really how important culture was in the success of this IPD project, that, you know, you should be patient and prepare for the culture change and new workflows, and to really be vigilant about communicating. And really that some of these were painful adjustments, and that they were really necessary, painful adjustments that the leader, like David Christian, who had really ensured that he wanted everyone to know that risk and profit scenario was a critical aspect of the success of that team. And really at the end of the day, it was the trust that they built in each other, the trust that they had in BIM that enabled them to really take it to the next level. So as we take a step back and really look at the lessons learned, I think we're entering a new paradigm of what we should really talk about BIM and think about BIM, and really understanding that BIM is really just a tool, and that there are many different tools between Revit and Tekla, and there's authoring tools, there's coordination tools, there's scheduling tools, but they're all just tools, and that the tool is really only as good as the people and the skill sets and the competency and the field and construction experience or design experience of those people using it. But finally, and probably the most challenging, is that those people, even if they do have great skill sets, can only be as effective as that process allows them to be. And, you know, I think too often we look to BIM or we look to new technology to solve a lot of these construction productivity imperative reports and some of the productivity studies that I'm sure you guys are talking about today in the Lean conference. I always like to look closer and deeper at the key factors and the root causes impacting that construction productivity imperative, and not seeing lack of technology or lack of BIM on there, but really around organization, communication, short-term planning, and a change in risk management. And even looking at, you know, the rise of technology across the last 50 or 60 years of this lack in productivity, and realizing that the robotic total station has been around, you know, since the 70s or the 80s. That CAD and digital drawings have been around, you know, since the 80s, and even BIM has been around for, you know, going on almost 20 years now. And so, you know, these really can't be the limiting factors to adopting BIM and seeing success within it. So, you know, we do wonder, why can't we just change that process? Why don't we just take that 3D model from the designer, pass that direct to the detailer, have that detailer come down and mark up directly within the model, and we've seen some success with in-model engineering review. And then that way we can let the detailer decide which aspects can go directly to a CNC fabrication, which still needs to go to a digital 2D drawing, really driving efficiency. However, too often we find ourselves, at least in the US, with legacy contract language that says, you shall not reference or for reference only of my model, and liability and contracts get in the way of really efficiency and lean BIM process. And that's really is why this quote is here, that is from John Machelmer from back in 2003, that especially in the traditional design, bid, build, contract structure that you can see here, virtually everyone in the construction supply chain works on contracts where the incentive is to maximize their gain at the expense of others. We're trying to drive efficiency when we're also incentivized to have conflicts and be deceitful to each other. So really need to make sure that we have the aligned incentives to drive the right process and technology forward. So when we look at this example or this chart here from Gartner talking about the investment in technology, and that construction compared to manufacturing or healthcare or education or finance is by far the lowest in investing in technology. And a lot of that's because there's just not as much of a incentive driver to do so, in my opinion. And so I'm not sure if any of you in the room have heard of or read The Innovator's Dilemma, which is by Harvard business professor Clay Christensen. But I love this quote here, that it's more likely that new firms with new business models and new areas of focus will leverage the financial and technological innovations that will change the nature of competition. And that's where I really believe that integrated project delivery or even some of the design build contracts that are allowing more collaboration, more sharing, more trust between designers and builders is going to be the future driver of this sort of competition that is going to see BIM and Lean really take hold on project teams. And for those of you who do want to dive deeper onto the understandings of how contracts and process and Lean work structuring apply in the BIM world, I co-authored an IGLC paper with Lori Spittler this last year, where some of our key discussion points on how to really change and redefine work structuring at this boundary of realization between design and construction is the fact that contracts impact the feasibility of systems level thinking. And that received traditions, which is the way we've always done it, does prevent innovation within the work structuring environment. I think some additional findings that we thought were interesting was that self-performed contractors actually take more responsibility for the project supply chain when they take on that risk, and that they see efficiencies from that. And that actually project supply chain should be restructured to reduce the variability of information released for construction. But at the end of the day, all of you are in Brazil, and I really want to provide my advice as far as where is Brazil along the, I'll call it the BIM hype journey. If you're familiar with the Gartner hype curve, you can see it in the bottom right corner between a technology trigger, the peak of inflated expectations, and then into the trough of disillusionment. So I think a lot of folks may say that globally that BIM is either in the peak of inflated expectations or the trough of disillusionment. I think it's interesting if we look at this survey graph here from McGraw-Hill, that from 2013 to 2015, that there was a huge spike in the implementation level quoted in Brazil. In fact, the largest overall spike of any country, and really the second largest overall by 2015 compared to the US. So I haven't been to Brazil. I can't say. I think that the US number is probably a little bit exaggerated if you were to ask me, but it'll be interesting to see, what is the reality today? What do you guys think in the room as you discuss this later today? Are these numbers correct? Are they not? And why or why not? But regardless, as you look at the World Economic Forum and what all the discussions are globally, you can see there's a great graph from their Shaping the Future of Construction report back in May that lists integrated BIM as the highest likelihood of sort of technology readiness as well as the highest market impact. So it's very prime for disruption in this industry. to see integrated BIM come together. And, you know, one thing that I think is very unique about Brazil's opportunity, or your opportunity now just getting into BIM, is that BIM today is a very different language than it was when I was implementing on-site in 2012, where we did have a notion that every piece of information would actually be inside of the BIM. And I think today we recognize that it's more about tagging and understanding references and how to have more of a data-centric approach to the project information. And that as we look at the landscape of all the different types of information, not just building information modeling, but you know, project data and you know, safety statistics or scheduling information or your task or issue list, any media, any photos or drone scans or other items. And then, of course, the classic collaboration comments that we see on drawings using Bluebeam or other tools. You know, these tools aren't going to go away, and we need to have a common data language that will allow all these different platforms to talk to each other. It's really no longer BIM in the center. BIM is just one spoke in that wheel of the integrated data workflow. So we talk a lot, and you know, really my focus is how do we adopt all of this BIM? How do we get much more broader, broad-based and value-added adoption of BIM? And I think the reality is that integrated BIM and data is probably a little bit further away, or it feels further away from reality than maybe we want it to be. And we are sort of held back by our more efficient ways to get our jobs done through Excel, through paper clipboards, or through a simple text message that it may be digital, but it's not integrated and it's not connected. And so really that my hope and my vision for how to bridge that gap is to say, for those who aren't ready for BIM, it doesn't have to be BIM, but let's at least get it to be digital. And there's some great iPad and other mobile apps, again, PlanGrid, Field Lens, Bluebeam, a ton of tools that are out there that can integrate and can allow the photo capture and can allow location tagging and information tagging and hyperlinks and date stamps, so that all this really great information is not just left on a piece of paper, it's stored within that database, within the iPad. And we can now take all this location and sheet information and profile information, we can load that back into the desktop and show it there. And then that's where we're going to link that back into that database. And we're really going to see that integrated BIM because it's come through that database first. And when it comes to adopting all of this and going back to that World Economic Forum, there's another really great graph in there that talks about the importance of different transformation areas, and this focus on, you know, people being the number one focus area, followed very quickly by adoption of new technologies, materials, and tools. And then the third one being that industry collaboration. And there was a great quote within there as well from Peter Bjork, who's vice president at Skanska in Sweden, that says, our business is really all about people. You can have equipment and financial resources, but to truly succeed in a business like ours, you need to have the right people in the right places. And so another great lean term is, you know, to plan the work and to work the plan. And you know, through Spectrum, we've been trying to do a lot more of these assess, align, advance, or A3 workshops, where you do want to start by understanding and assessing where is the current state, where is BIM being used, why does that team really care to use BIM, and how are we going to define that value? And then bringing that team together to really align, okay, within that current process, what are the best tools, what are the best uses of BIM that are going to fit within our current design process? And then really align ourselves together on what that plan is, advance that forward, document what the technology needs are, begin with the end in mind, and have those key performance indicators that are going to take us to the finish line. And so, you know, if I could leave with one message of, you know, what should you do to be successful with BIM, or what technology, you know, unfortunately, it's not a certain technology, and it's not a certain process either, and it's not a particular type of people. It's really a balance of all three, and that we've got to have really sound BIM and data standards. We've got to have, you know, lean and digital workflows that are really, you know, allowing those who need to do their work to get their work done, but also capture the data in a very integrated and lean way. And then also make sure that the people are incentivized, and that there is shared risk and reward to want to take some of these innovation risks and see some really great BIM collaboration and lean innovation happen. So with that, I will wish you all good luck on your lean and BIM journey. And as long as all the audio is working, we'll go through some questions and comments. Thank you.